Oumuamua, the enigmatic space object whose unusual trajectory captivated global attention in late 2017, is once again making headlines, this time for a more alarming reason. The object is on a collision course with Earth and is expected to impact in just a few weeks. What's more troubling is that Oumuamua is showing no signs of deceleration. This situation has raised concerns. Could it signal the start of a disaster? To unravel the implications of this potential impact, we must delve deeper into the subject. Stay with us until the end of this discussion to explore what fate might await our planet. When hearing the term alien probes, one might think of classic science fiction, where extraterrestrials examine humans with strange devices. Alternatively, some may recall Oumuamua, the odd, cigar-shaped object that briefly passed through our solar system a few years back. Plasma physics expert Avi Loeb even speculated that Oumuamua could be an alien spaceship, a notion that, despite sounding like science fiction, has captured the fascination of scientists. However, significant challenges would confront an alien civilization attempting to send a probe across the vastness of space. For instance, a probe from the Andromeda Galaxy would need to cover a staggering 2.5 million light-years, equivalent to 6 trillion miles per light-year, to reach Earth. Moreover, time is a crucial factor. How could extraterrestrials ensure their probe arrives before their own civilization faces extinction? Even if they could solve these issues, the probe would still need to endure the extremes of space, such as radiation, space debris, and other hazards. Constructing such a durable probe, possibly from a substance as strong as diamond, would be essential to withstand the rigors of interstellar travel. In 2017, astronomers finally encountered the kind of intergalactic visitor they had long awaited. Perhaps, in the future, we may indeed discover that we are not alone in the cosmos. Oumuamua's path was highly unusual. Instead of following a predictable, circular orbit, it traveled in a hyperbolic trajectory, passing the Sun with almost no gravitational effect. This high-speed object, resembling a cosmic projectile, was first observed on October 19, 2017, by University of Hawaii astronomer Rob Werrick. At that point, Oumuamua was already 21 million miles from Earth and would only approach as close as 15 million miles before departing the solar system with a push from the Sun's gravity. Hurtling through space at an astonishing 54.2 kilometers per second, Oumuamua presented a fleeting opportunity for study. Its rapid pace and small size allowed astronomers only a few weeks to examine it closely. Fortunately, the Hubble Space Telescope and other powerful observatories captured remarkable images, showing Oumuamua as a tiny dot in the vastness of space. It continued its journey toward the constellation Pegasus before vanishing into the distant Kuiper Belt, a region beyond Neptune filled with frozen objects. Could Oumuamua return someday? What exactly was this interstellar visitor? While some speculate it might be an alien probe, others believe it could be a dead comet that lost its gases over billions of years. Whatever its nature, Oumuamua's brief visit has sparked considerable interest among scientists and space enthusiasts, igniting curiosity about the mysteries of the universe. Oumuamua's journey through space presented an enigma. While accelerating away from the Sun, the Hubble Space Telescope observed a peculiar phenomenon, a non-gravitational acceleration. Typically, comets emit dust and water vapor, forming a tail that propels them forward. However, unlike conventional comets, Oumuamua showed no signs of releasing water or other volatile substances. So, what could this strange object be? Several theories have emerged as scientists attempt to solve the puzzle of Oumuamua. One popular hypothesis suggests that it might be a piece of nitrogen ice. Arizona State University researchers Alan Jackson and Stephen Desch proposed that Oumuamua could have been knocked off a Pluto-like object by a massive impact. The Sun's heat, they argue, may have provided the extra push, especially if nitrogen ice was present, giving Oumuamua its pale appearance. According to this theory, Oumuamua may be smaller than initially estimated. Another idea, proposed by Jennifer Bergner of Berkeley University and Darrell Seligman of Cornell University, suggests that cosmic rays reacted with surface ice in interstellar space, releasing hydrogen gas trapped within water molecules. When Oumuamua warmed up, the hydrogen could have leaked out, altering the ice's crystal structure and giving the illusion of motion. Additionally, some scientists speculate that Oumuamua could be a solar-powered spacecraft. This intriguing theory, put forth by Harvard astronomers Avi Loeb and Shmuel Bialy, posits that the unusual characteristics observed in Oumuamua might stem from an artificial source, hinting at the possibility of alien technology. Oumuamua's trajectory, pointing to an extrasolar origin, supports this hypothesis. Since astronomers couldn't capture close-up images, its exact size and shape remain unknown. To estimate its size, scientists rely on Oumuamua's brightness and their knowledge of how comets and asteroids reflect light. Many researchers question the comet theory because Oumuamua lacks a coma or tail, and its rotation period, a hallmark of typical comet outgassing, hasn't been measured. Some suggest that Oumuamua's motion could be the result of a force that separated it from its parent object, although this is disputed by the persistent non-gravitational acceleration it exhibited. Another compelling hypothesis involves sunlight. If Oumuamua is incredibly thin, between 0.3 and 0.9 mm thick, solar radiation pressure could explain its observed movement. This theory proposes that Oumuamua might function as a light sail, technology that has been tested in space missions such as NASA's NanoSail, D2, and Japan's Ikaros probe. These light sails travel through space by harnessing radiation pressure, pushing them along their paths. The kinetic energy of photons, based on calculations, suggests that a light sail like Oumuamua could potentially travel at least 16,000 light-years beyond its home system, surviving a prolonged journey into interstellar space. We seriously consider the possibility that Oumuamua is either a piece of space debris or an alien vessel. It may have arrived here by accident or could have been intentionally sent to observe our solar system. The unique discovery of Oumuamua supports such theories. Finding it as we did suggests that every star in the Milky Way likely ejects numerous objects throughout its existence. If Oumuamua is part of a random population of objects, this would be one of many that have passed through our solar system, though there are not many known objects like it here. Additionally, determining Oumuamua's exact origin is difficult due to how its speed aligns with the local standard of rest, a region of the Milky Way. As it moves beyond the outer solar system, it travels too quickly for conventional rockets to catch up, though projects like Breakthrough Starshot might eventually make it possible to send small robotic probes with sails to pursue it at high speeds. Studying Oumuamua's brief visit helps us prepare for similar encounters in the future. Even if we can't observe it directly, astronomers can better study other remarkable objects by making detailed observations and applying insights gained from this encounter. Preparing for the return of an Oumuamua-like space probe would require considerable planning and infrastructure. It may even be worth contemplating the construction of a specialized shipyard should something extraordinary re-enter our solar system. The prospect of sending a spacecraft after such an object raises other challenges, especially with the need for a more advanced understanding of dark energy to develop spacecraft capable of such a pursuit. Although sending a craft after Oumuamua is conceivable, it would be a daunting task due to its hyperbolic excess velocity of $5.50 per year. Within the next 2 years, Oumuamua will have traveled beyond Saturn's orbit, making it the fastest object ever launched into space by humans. Designing a vessel capable of pursuing it would demand high levels of innovation in propulsion technology, perhaps even more advanced than solar sails, possibly something as exotic as a wormhole. Wormholes, first theorized by Albert Einstein and Nathan Rosen in 1935, represent hypothetical shortcuts through space and time, connecting distant points across the cosmos. Einstein's general relativity equations suggest that wormholes, also known as Einstein-Rosen bridges, could exist, although none have been confirmed. Some theories even propose wormholes linked to black holes, but it remains uncertain whether objects could survive falling into them. Einstein's concept of spacetime as a fabric across the universe, warped by mass and energy, forms the foundation of gravitational effects. They are not due to direct gravity but to the warping of spacetime itself. This theory also introduces the concept of wormholes, suggesting that if such portals opened in spacetime, they could connect different regions of the universe. Various types of wormholes have been proposed. Some, frequently depicted in science fiction, serve as movable bridges connecting distant points in the universe, such as in Star Trek, Deep Space Nine. Non-traversable wormholes are impassable, collapsing or offering no exit. One-way wormholes allow travel in only one direction, while two-way wormholes permit round trips. Wormholes within our universe are termed intra-universe wormholes, while inter-universe wormholes might connect to parallel universes, like the wormholes in comics that bridge DC and Marvel universes. Although not yet navigable, wormholes continue to fascinate scientists and inspire speculation. Einstein's equations suggest the possibility of wormholes inside black holes and the existence of white holes, which could release materials like dark energy. These ideas, while grounded in mathematical theories, have yet to be proven. However, Einstein's theory of general relativity lends theoretical support to wormholes, even if they remain largely in the realm of conjecture. The idea of wormholes continues to spark curiosity and speculation, reminding us of how much is yet to be learned about the universe. They could represent unseen gaps in spacetime that no object has yet passed through, though it is not impossible that they exist. Science fiction often imagines spaceships tearing through spacetime to form wormholes, suggesting we may one day create our own. The vastness of space, stretching across trillions of light years, leaves much undiscovered. Despite our best efforts, we observe only a small fraction, uncovering distant stars, galaxies, and new moons within our solar system. Given our limited capacity for space exploration, it's understandable that phenomena like wormholes might evade detection. The Big Bang Theory, which proposes that the universe began with a massive explosion, provides one potential explanation for the existence of numerous spacetime holes. This event could have created a network of wormholes connected by cosmic strings. Perhaps wormholes, rather than black holes, sit at the centers of galaxies, linking them across vast distances. Gravity would likely cause wormholes to collapse over time, yet cosmic strings might provide the energy needed to keep them open. The dream of easy cosmic travel fuels scientific ambitions and inspires science fiction. Imagine if humans could build wormholes, embarking on interstellar journeys that echo current Mars missions. Launching into space, creating a wormhole larger than Earth's gravity, and arriving on Mars immediately would save resources and speed up Mars colonization. Expanding this concept could bring us to Alpha Centauri or Saturn's moon Titan, potentially suitable future human habitats. Wormholes would serve as shortcuts, allowing us to build ships that could withstand the journey rather than requiring vessels that can traverse vast distances. Though only a vision now, the idea captivates scientists and science fiction enthusiasts alike. A somewhat similar idea to wormhole travel is Freeman Dyson's proposal of an ALO drive, which suggests constructing a launch pad beyond the asteroid belt. This drive, similar to a conveyor belt, could accelerate spacecraft using a warp bubble by curving spacetime around the vessel to simulate propulsion. This concept faces challenges, particularly with the need for negative mass, a phenomenon yet to be fully understood by astronomers. Building a warp engine is fraught with challenges, as illustrated by the remarkable recent sightings of 2I Borisov, an interstellar object similar to Oumuamua, captured by the Hubble Space Telescope. These visitors from beyond our solar system intrigue scientists, offering invaluable lessons that deepen our understanding of the universe. Despite the technical and logistical obstacles, these explorers of space make significant strides, fueling our collective curiosity about the cosmos. In August and September of 1977, two spacecraft, the Voyager twins, embarked on a historic mission beyond our solar system, taking advantage of a rare planetary alignment. This alignment allowed the Voyagers to launch in a straight path toward Jupiter, using its powerful gravitational field to slingshot them toward Saturn. Once at Saturn, the twin Voyagers parted ways. Voyager 1 aimed upward into uncharted interstellar space, while Voyager 2 continued on a winding journey through the outer planets, encountering Neptune and Uranus along the way. Each close encounter transformed distant, hazy specks into dynamic worlds, offering a wealth of insights into the universe's mysteries. At Jupiter, Voyager captured breathtaking images of intricate jet streams swirling in mesmerizing patterns. It observed Io's volcanic eruptions, distorted by gravitational forces, and glimpsed Europa's frozen surface, concealing an ocean beneath. 2 years later, the Voyagers reached Saturn, a planetary marvel with its majestic rings, previously thought to be smooth but now revealed as intricate with grooves and tiny moonlets circling along the edges. Passing through Titan's methane-rich atmosphere, Voyager observed Iapetus, whose contrasting light and dark hemispheres resemble a cosmic yin and yang. While Voyager 1 departed Saturn to venture further into the cosmos, Voyager 2 continued onward, providing invaluable data from the outer reaches of our solar system, shaping the foundation for future exploration. Beyond mere observation, the Voyager mission conveyed a powerful message to the stars. Each spacecraft carried a golden record, encapsulating the essence of Earth's sights and sounds, inscribed with messages of peace and friendship. These records, intended to outlive Earth itself, drift through the vastness of space like fingerprints in gold. As Voyager 1 bade farewell to our planetary neighborhood, it directed its cameras back toward Earth, capturing an iconic family portrait of our solar system. This image, famously described by Carl Sagan as the pale blue dot, symbolizes our humble place in the grand cosmos, a tiny speck amidst the immensity. No other spacecraft has ventured so far or witnessed so many cosmic wonders as the Voyagers. Far in the future, they may encounter another civilization, long after humanity itself may have faded from existence. Yet these silent emissaries will continue their journey, carrying the echoes of our presence, leaving a legacy of curiosity and exploration that signifies our once bold reach among the stars. NASA's New Horizons spacecraft set off on an extraordinary journey toward the distant dwarf planet Pluto in January 2006. This remarkable spacecraft became the first human-made object to approach Pluto, but its mission didn't stop there. It aimed to explore even farther, reaching for the mysterious Ultima Thule in the Kuiper Belt, an enigmatic region on the outermost edge of our solar system. To achieve its mission, New Horizons had to pass through the asteroid belt between Mars and Jupiter. This region, far from being barren, is filled with countless rocky bodies, creating a celestial highway for space explorers. In June 2006, New Horizons encountered asteroid 132524 APL, a small yet significant milestone along its route. Though it appeared as a blur from a distance, this rocky traveler, about 1.6 miles in diameter, gave New Horizons a chance to test its instruments, which were still being calibrated as it zoomed by at 63,000 miles per hour. After traversing the asteroid belt, New Horizons approached the gas giant Jupiter in 2007, capturing breathtaking images. Jupiter's massive gravitational field provided a cosmic slingshot, propelling New Horizons toward Pluto and trimming 3 years off its journey, increasing its speed by an impressive 8,700 miles per hour. This encounter with Jupiter not only accelerated New Horizons but also enhanced its scientific data, marking a crucial milestone in its mission. So, what are your thoughts on Oumuamua and the potential insights it might reveal? Share your views in the comments section below. If you enjoyed watching the video, don't forget to like, share, and subscribe.